Okay, so we are going to be looking at some certain special types of right triangles. They have some very nice properties. Um, yeah, some very nice properties. The first type we're going to be looking at is a 45, 45, 90 triangle. So this is a triangle where right triangle specifically, so it has a right angle, where the other two angles are 45 and 45. Okay, so the 90, 45, and the 45. The side lengths and the hypotenuse all follow a specified pattern when you have a 45, 45, 90. Okay, the legs are both equal to each other, and the hypotenuse is equal to the leg times the square root of 2. So you can always find a specific length because of this property. Okay, so if we look at what is this one supposed to be? Oh. Let me go ahead and fix this one real quick. I think this is supposed to be here. There we go. Okay, so find the missing lengths of the special right triangle. Okay, we're going to just assume this is a 45, 45, 90. Okay, so this is a 90-degree angle, and these are both congruent, meaning they're both 45-degree angles. Okay, so the hypotenuse is equal to 1. Okay, so the side lengths are x and y, but remember these side lengths are the same. So we'll just call them both x because they're both the same value. Okay, well what we know is that the hypotenuse is equal to the side length multiplied by the square root of 2. So we can say that x times the square root of 2 is equal to 1. And what that means is that if we want to know what x is, then we divide both sides by the square root of 2. So the x length is 1 over the square root of 2. So the side lengths are 1 over the square root of 2. Now, I don't know if everybody recalls, but you don't want to leave a radical in the denominator, so we will multiply the numerator and denominator by the square root of 2, okay, which means that x is going to be expressed as the square root of 2 over 2. This is a better way since we don't have a radical in the denominator. Okay, so this would be better form. So the side lengths are both square root of 2 over 2. And this is all because of the property that it's a 45, 45, 90 triangle. Let's take a look at number 2. Find the missing side length, simplify all radicals. Okay, so this is a 45, 45, 90. What we're given is the hypotenuse, so both of these are equal to each other, both the legs. We know that the hypotenuse is equal to the leg times the square root of 2. So the hypotenuse, which is 6 square root of 2, is equal to the leg x times the square root of 2. I can solve this for the leg x by dividing by the square root of 2. So what I get is that the side length x is equal to 6. Both of these sides are equal to 6. 6, 6, and 6 square root of 2. Okay, this property is going to work for any 45, 45, 90. All right. Now, one thing to keep in mind is that if one of the angles is 45 and one of them is 90, then the last angle has to be 45 because this has to add up to 180. And the only way that's possible is if both of these are 45. So if one of them's 45, they are both 45. Okay, so this is a 45, 45, 90, which means that the legs are exactly the same, and the hypotenuse is equal to the leg times the square root of 2. So instead of using x and y, I'm just going to call these both x, because they're exactly the same. So I know that the hypotenuse, which is 5, is equal to the leg times the square root of 2. I can solve this for the leg, x, by dividing both sides by the square root of 2. So I get 5 over square root of 2 is equal to x. Now remember, we do not leave radicals in the denominator. Okay, so I'm going to multiply square root of 2 over square root of 2 to get rid of the radical in the denominator, because the square root of 2 times the square root of 2 is 2. So this is 5 root 2 over 2, and that is my side length for both of these. Both sides are 5 root 2 over 2. Okay, so you always have to rationalize the denominator, okay? Denominators have to be rational. Okay, you can't leave it as an irrational square root of 2 in the denominator. That's not okay. Number 2, find the missing side length, simplify all radicals. Okay, so this is 90, 45, which means this other one must be 45 degrees. I have one of the side lengths, which means I know that this side length is also 2 root 6. And the hypotenuse is going to be the leg times the square root of 2. So the hypotenuse A is equal to the leg 2 square root of 6 times the square root of 2, which gives me 2 square root of 12. Okay, but remember, we need to simplify 2 square root of 12, because square root of 12 can be expressed as 4 times 3, and the square root of 4 is 2. So this is 2 times square root of 3, or 4 square root of 3. So the hypotenuse in this case is 4 square root of 3. Number 3, find the missing side length, simplify all radicals. Okay, so we got a 90 degree, got a 45, which means this one is also 45, and we have a leg, 3 square root of 6 over 2, which means that this leg is also 3 square root of 6 over 2, because this is a 45, 45, 90. Both legs are the same. And the hypotenuse is equal to the leg times the square root of 2. So I have x, which is the hypotenuse, is equal to the leg, 3 square root of 6 over 2, times the square root of 2. Okay, so that's 3 square root of 12 over 2. And if I simplify this, remember that's 3 times the square root of 4 times 3. And the square root of 4 is equal to 2. So that's 3 times 2 times the square root of 3 over 2. The 2 in top and bottom cancel. So it's just 3 square root of 3. Okay, so the side length, the hypotenuse here is 3 square root of 3. And that is all the sides for this 45, 45, 90.